Hello dear students, this is your engineering mathematics 3 lecture. The topic is Z transform. Last two lectures we have discussed the transform of some standard sequences, properties of Z transform, some examples on Z transform. Again, we are going to discuss few examples in this lecture. Z transform. Z transform is the topic from second unit. Now see the new example here. Find the Z transform of f of k when f of k is equal to sine of k pi by 4 plus alpha, k is greater than or equal to 0. Now the sequence is here sine of in bracket k pi by 4 plus alpha. Now use here the formula sine of a plus b. First simplify the sequence and then we will find the Z transform for this sequence. Now sine of a plus b means the formula is sine a cos b plus cos a sin b. Now the value of a is here k pi by 4 and value of b is alpha. So the formula is here sine of k pi by 4 into cos alpha plus cos of k pi by 4 into sin alpha. Now taking Z transform on both sides, we have Z transform of sine of k pi by 4 plus alpha is equal to, now cos alpha is a constant term, so you write it outside the bracket, into Z transform of sine of k pi by 4. Because sequence in RHS, there are two terms. In these two terms, that sine k pi by 4 is the sequence term and cos k pi by 4 is the sequence term. Cos alpha and sin alpha, these are the constant terms. So here in RHS, it is equal to cos alpha into Z transform of sine k pi by 4 plus sin alpha constant. So write as it is sin alpha into Z transform of cos of k pi by 4. Okay. Now next step, cos alpha as it is. What is the Z transform of sine k pi by 4? You use the formula Z transform of sine alpha k. So written or we have discussed the results Z transform of some standard sequences. In that standard sequences, one of the standard sequences sine ak. So we know the formula for Z transform of sine alpha k. And in place of alpha, the term is here pi by 4 only. Okay. So it is the next step. It is equal to cos alpha as it is. The transform of sine k pi by 4, which is z into sine pi by 4 upon z square minus 2z cos pi by 4 plus 1 plus now second term sine alpha as it is. The transform of cos k pi by 4. Here use the formula for Z transform of cos alpha k, standard sequence cos alpha k. Alpha, in place of alpha, there is the coefficient pi by 4. So sin alpha as it is, Z transform of cos of k pi by 4 is Z into bracket Z minus cos pi by 4 upon Z square minus 2Z cos pi by 4 plus 1. Okay, now simplify this term, cos alpha as it is, Z as it is, sin pi by 4, sin 45 is 1 by root 2. Right, 1 by root 2 upon Z square minus 2Z cos pi by 4 means 1 by root 2. So 2 upon root 2 is root 2. It is Z square minus root 2Z plus 1 plus sin alpha. Numerator Z into Z minus cos pi by 4 1 by root 2 again. Bracket complete upon Z square minus 2Z cos pi by 4 1 by root 2 into 2. So the middle term is root 2Z plus 1. Okay, so this is your answer that Z transform of sine k by 4. Next example. Find the Z transform of f of k if f of k is equal to e raised to minus ak into cos b. So, what is the Z transform of this sequence? The product of two sequences e raised to minus ak into cos bk. Now there is one formula Z transform of e raised to minus ak into f of k is equal to f of e raised to a into z. This is the Z transform of standard sequence. To use this property here, now f of k is, if we compare the given sequence with this sequence in formula, e raised to minus ak into f of k with e raised to minus ak into cos bk. Then the value of f of k is here cos bk, and the z transform of cos bk is nothing but z into bracket z minus cos b upon z square minus 2z cos b plus 1. This z transform is using the formulas, using the formula of standard sequence cos alpha k. In place of alpha here the term is b. Only difference is that we have already discussed in first lecture of Z transform, the Z transform of some standard sequences. There we have discussed the formula of Z transform of cos sequence. Okay, we are using that formula here only. Then the Z transform of product of two sequences e raised to minus ak into cos bk. Now use this formula here. Now the Z transform of cos bk is this term here. It is equal to f of z, capital F of z. Okay. Now this term is here. We can write here so that easily we can understand the term. Here it is f of z. Equal to this term is Z transform of cos bk is nothing but your f of z. In this f of z now you replace your z term by e raised to a into z. So every term in f of z in z transform of cos bk, every term of z you replace it by e raised to a into z because of this formula. So here this of z e raised to a into z in bracket e raised to a into z minus cos b upon this e raised to a into z minus e raised to a into z cos b plus 1. So this is the example based on this formula. The transform of product of two sequences. When one of them is exponential sequence, then how to write it. So this example after next these two examples you take it as a homework. You try to solve these two examples using the same formula here. Next is find the Z transform of f of k if f of k is equal to 2 raised to k into cos of 3k plus 2 when k is greater than or equal to 0 here. Now Z transform f of k is here 2 raised to k into cos of 3k plus 2. Now Z transform of f of k is equal to f of z. This is the formula. Then Z transform of a raised to k into f of k is equal to f of z by a. This is the change of scale property of Z transform. We are going to use this property here because there is product of two sequences. One of them is f of k, one of them is in the form of f of k. Cos of 3k plus 2 is your f of k and 2 raised to k is in place of a raised to k. So you first find the Z transform of f of k means Z transform of cos of 3k plus 2. Then we will use the change of scale property here. So we first simplify the sequence cos of 3k plus 2. There the formula of cos of a plus b. Formula of cos of a plus b is cos a cos b minus sin a sin b. So apply the transform of the transform cos of 3k plus 2 is equal to the transform of RHS. Now in RHS term cos 2 and sin 2 these are constant terms, so you will substitute it. Cos 2 as it is, the transform of cos 3k minus sin 2 as it is, the transform of sin 2. Okay. So the transform of cos of 3k plus 2 is equal to cos 2 as it is because it is constant. Then the transform of cos of 3k. Use here the formula of the transform of cos 3k. The transform of some standard sequence. Z into bracket z minus cos 3 upon z square minus 2z cos 3 plus 1 minus sin 2 as it is So Z transform of sin 3k. Use here the formula of Z transform of sin alpha k. So in place of alpha there is 3. So it is Z into sin 3 upon Z square minus 2Z cos 3 plus 1. Okay. So this is the Z transform of cos of 3k plus 2. Now we want Z transform of 2 raised to k into cos of 3k plus 2. So use here the change of scale property. In place of a, the value here 2. So and the formula is that property is Z transform of a raised to k into f of k is nothing but to the f of z upon. Now this is your f of z term. Yes. F is nothing but your f of z term here. Okay. Is equal to f of z. This is f of z. Now in this term, you replace that z by z upon 2 because we are using this property, change of scale property. In place of 2, the term is z2. So you replace z by 2 in f of z. This is your f of z term. So replace every term of z by 2. So cos 2 as it is, replace every term of z by 2. Z by 2 into bracket z by 2 cos 3 upon z by 2 also into z by 2 cos 1 minus sin 2 as it is z by 2 into sin 3 upon z by 2 whole square minus z by 2 cos 3. Every term of z is replaced by z by 2. So z transform of 2 raised to k into cos of 3k plus 2. So this is the example here. Now z transform of 2 raised to k into cos of 3k plus 2. Okay. These are the change of property. You can find the transform of this sequences. Example is here. Find the Z transform of f of k if f of k is equal to k into 5 raised to k. Find the Z transform of f of k if f of k is equal to k into 5 raised to k. The condition for k is k greater than or equal to 0. Now there is product of two sequences. One is 5 raised to k, which is f of k, and k. Multiplication by k property. Using multiplication by k property, you can find the Z transform of f of k is equal to k into 5 raised to k. Now first Z transform of 5 raised to k when k is greater than or equal to 0. Use here the Z transform of some standard sequences. One of the formula Z transform of a raised to k when k is greater than or equal to 0, it is equal to z upon z minus a. Now in place of a there is 5, so you replace a by 5. So z upon z minus 5 mod z is greater than mod 5. Okay. Now use your multiplication by k property to find the z transform of k into 5 raised to k. So it is equal to minus z into d by dz of f of z. Now f of z is this function here. Here in this example, this term is f of z. Z upon z minus 5 is nothing but the f of z. Now you differentiate this f of z with respect to z into minus z. This is the property k multiplication by k by multiplication by k property. We have already discussed it in first lecture of Z transform, properties of Z transform. So you see that video lecture of first video lecture of Z transform. There I have explained the properties of Z transform, and one of the properties is multiplication by K property, and we are using that property here. The transform of K into 5 raised to K is equal to minus Z into derivative of f of Z is here, Z upon Z minus 5. We differentiate it with respect to Z using the multiplication by K property. Now, how to simplify, how to differentiate it? This minus Z as it is, use here u upon v rule to differentiate it, because the term of Z is there in numerator as well as in denominator. So we have to use u upon v rule here to differentiate the function. Okay. So u upon v rule, that v as it is, Z minus 5 as it is, into derivative of u, derivative of Z is 1 with respect to Z, minus, now u as it is means numerator term as it is means Z as it is, into derivative of denominator term. Denominator is Z minus 5, derivative with respect to Z is 1. So minus Z, that is 1 upon Z minus 5 whole square. Z minus 5 whole square. Now simplify minus Z as it is, in bracket of Z minus 5 minus Z. It is minus 5 upon Z minus 5 whole square. So minus minus plus, so this 5Z upon Z minus 5 whole square. So Z transform of K into 5 is K is equal to 5Z upon Z minus 5 whole square. This is the example of multiplication by K property. So here, all the types of examples of Z transform are over here. We discuss all the types of examples of Z transform. So, thank you.